everyone, welcome to another episode of Practically Intelligent. Today we have on Curtis Northcutt, founder and CEO of CleanLab.ai. CleanLab is an automated no-code tool to curate and automate your labeling operations. The company was founded by three PhD founders out of MIT. And today we're talking to Curtis about the history of data ops and data quality and core concepts in machine learning related to data labeling, and how we actually think about scaling that and creating trustworthy models and data.
Yeah, MIT. I've heard of them. So the interview is quite fun because, yeah, to your point, we come at this from a lot of different angles, from core traditional machine learning all the way to, well, what's the bottom line? How much money can you actually save when you put these processes in place? And I think we go in a lot of different directions in a relatively short amount of time. So I'm pretty excited to jump right in.
Let's do it. Awesome. Curtis, thank you so much for coming on.
Yeah, glad to be here.
I wanted to start by grounding us in a simple but very nuanced question. What to you at CleanLab is the difference between reliable and unreliable data?
It's a good one. So reliable data historically meant you need imputation, which means you have some structured data set like a CSV file, and it misses values, so you have some blanks, and that was considered unreliable. And there's a lot of companies that have built what's called ETL, extract, transform, load, or ELT, depending on if it's on the cloud or done before the cloud. And what they're basically doing is making sure that doesn't happen and making sure that data is reliable in the sense that it exists and it's the right type and it's going to the right places. At CleanLab, when we say reliable, we mean it like what a human means. So for example, if you have an image and you're in a data set of animals and that image is not an animal, that is not reliable. And we would call that an outlier. Another example of unreliable data is something that is in images of, let's say, cell phones and laptops, and it's a picture of a laptop and it's labeled cell phone. So that would be unreliably labeled, meaning it just has the wrong label. And there's a bunch of these. Other things are text, for example, that has PII issues or toxic language or inappropriate content or the wrong language. So these are all examples of unreliable data that semantically, the data is there, it's the right type from like a syntactic structure, it's all the rules are correct. But now we're talking about when you actually get value as a business or a customer from that data, you're not going to get the value you want because the actual data itself is unreliable from a semantic standpoint.
So you're touching on, I mean, on its face, a relatively simple idea, but something that a lot of people tend to overlook, which is that reliability. To your point, it's not one thing, and it's barely even two or three things. It's the idea that you can go in and trust something. Which is almost like the other side of reliability. If something is reliable, you trust it. And at CleanLab, it sounds like the main vision here is to make sure. I mean, look at their website, right? It's data that you can trust, and there's a lot of dimensions to that. So I'm curious myself, what are some concrete examples of ways that you are making data actively more reliable? If you want to give us an example.
Yeah, for sure. A lot of folks right now are fine-tuning LLMs, and they would like the outputs of those LLMs to produce something that doesn't yell at the person or cuss them out or do something that's inappropriate. So that's an example of an LLM being unreliable. The way that you make an LLM more reliable is when you fine-tune that LLM, when you train it on examples. It's called instruction-based tuning, where you're basically fine-tuning a model with both the examples of both the original prompt and then what you expect the response to be. So what we would do is we'd run CleanLab through all the responses of the fine-tuning data set and filter out all the stuff that would be problematic, like bad language, PII, email addresses, URLs, credit card numbers, informal language, inappropriate remarks. And then when you now fine-tune your model, it knows not to do those things. And so that's an example of how you can now have a model that produces more reliable output where reliable in this case just means it talks the way that you would like it to talk.
And something that you're implying there, which I want to make extremely explicit for everybody, which is reliable data is not the end goal. It's kind of the starting point for reliable models and reliable AI ecosystems, right? In a lot of ways, having data you can trust by itself is often useless. The whole point of that data was to be powering something bigger than the data, than the rows and columns itself. And most of the time these days, those are LLMs, those are multimodal models. So what you're doing at CleanLab is not just creating data you can trust, but that's the foundation for models, and therefore features based on those models are going to be reliable themselves. And I mean, I think you kind of, for me, what really rings true is a recent story about Air Canada's chatbot, right? When Air Canada's chatbot promises a refund policy, I believe it was like a refund policy that doesn't actually exist, that model, that to that person, is unreliable, and it's building that ecosystem. So now, the idea, Curtis, that you've been working on this as an entrepreneur is pretty well known. But before CleanLab, even the idea of reliability and confidence was something that you focused on a lot when you were getting your PhD at MIT. Can you tell us a little bit about the inspiration? Like what kind of drove you to this field, to this industry? Like what's the story there?
100%. It was trying to change the world. Fundamentally, I wanted to democratize education. I think I would be remiss, and I think the people listening to this would also want to know, everything that we're going to talk about is automated. And that's very different. A lot of companies are like, data you can trust, and then they send your data off to the Philippines, and then 50 people review it, and then they send it back. That is not what we're talking about here. So everything that we're going to talk about, everything we've already talked about, is systematic, algorithmic, with reliability, quality scores added to every data point in a way that you can verify and actually show that above this threshold, here's the probably approximately correct bounds that this is actually reliable data, and below this threshold, you need to do whatever. Okay, so with that in mind, I got to MIT in 2013, did my PhD there. I worked with Isaac Chuang, who's commonly known as the first person to ever build a working quantum computer. So sometimes called the inventor of the quantum computer. And what he really cared about was, how do you take data signals from a quantum computer and be able to reliably understand what that quantum computer is doing? And when you have atoms that are in different states, how do you take measurements and velocities and particle speeds, and how do you measure that in a way that's reliable? At this time, in 1998, it was a 2-bit quantum computer, and they're constantly increasing them, but that was literally the task. And the way that this was done is a combination of tremendous engineering work, but also systematic theory that's provable and guaranteed, called quantum information theory. And I worked with Ike for 8 years at MIT, and what we developed was a way that you could take that same theory and apply it to arbitrary data. Because if you think about it, a quantum computer is arbitrary information. It's just a computer. It doesn't care if the data is images. It doesn't care if the data is audio or text. And so that's one of our unique differentiations, is we were able to invent an algorithm that is a framework of algorithms called confident learning, that allows you to reliably and systematically, in a provable way, find errors in data automatically and fix them for any type of data, which is very unique. You have self-driving car companies, you fix image data. You've got LLM companies, it's text data. But with CleanLab, it's any type of data. And so the problem that I first wanted to solve was democratization of education, because I was working as the first research scientist at MITx, which is a subset of edX, a competitor of Coursera, if you've ever taken online courses like Andrew Ng's deep learning course. And we needed to detect who was cheating or not so we could validate certificates. So you've got all this education data, and you're trying to predict if someone's cheater or not, which is a label. And it turned out that machine learning failed. And so I talked to the smartest people I could find at MIT, and people who had done machine learning for 20, 30 years, like forefathers of the field. I talked with Tommy Yakla, who's one of the first inventors of some of the probabilistic graphical model work and pushed SVMs and really OGs in the field. And at that point, it's now 2013, 2014, machine learning did not work. There was no actual reliable multi-classification algorithm that could actually train on erroneous data. And so I spent the next like 4 to 8 years developing the theory and algorithms that eventually turned into CleanLab. And now, of course, we've been building a business on it for, about half a decade.
It's interesting, Curtis, because you started working on this and innovating, you know, before the Transformer era, and during a time where really this entire idea of data curation was about throwing headcount and essentially all about labels. One thing I'm curious about is that's changing now, right? And companies, organizations are making they get this concept, even outside of the ML org, of data being the new oil, of curating a knowledge base that's proprietary, of imbuing that into your workforce, enabling automation. Talk to us a little bit about how data curation and scalable data curation in companies has changed over the last couple of years. I know you talked about automation, but give us a little history lesson on, scale came into this space, you were innovating, seeing what was happening there. Talk to us a little about the changes of the space and the context and eyes from one of potentially your customers.
100%. So I'll first talk about how things have changed, and then I can focus on a customer use case. I have a slide that I usually show for this, but I know that doesn't work for this format. But it basically shows 2013 to 2016. How do we do data curation at enterprises? Well, and it's worth noting, I did some kind of research contingent position or research scientist position or internship at Amazon, NASA, General Electric, Microsoft, Google, and Meta, and Oculus Research. And so I've done the gambit. I've seen a lot of these places and how they work. And most of what I'll share is rhetoric from firsthand experience. And what typically was done in data science teams and machine learning teams is a bunch of ad hoc Jupyter notebooks where you would basically write a bunch of rules to label things internally, share it around, get a bunch of people to do it. Then eventually people realize, wait, we're paying, whatever salaries from 150 up to 400 something K in order to have research scientists label data. Maybe we can do this more efficiently. And so that was like 100x cost and time. And so 2016, Alex Wang has a great idea, and to say, hey, look, let's just have sort of a human labor force that's affordable and overseas, be able to sort of ship data for AI, and they can label it for you, but they're not experts. And so if you're a self-driving car company and you have an image of a road and you don't even live in America, it's difficult to know, is that exactly a stoplight or a road? And so the way you deal with that is you get 50 non-experts to all label something and come to consensus. And so there's a few issues with that, but it's a good approach, and that's done very well, right? It provided real value, and it's a good approach. The downsides are you've got to pay a lot of people. You have to distribute it out. You have to send the data out to third parties. So it creates data trust on sort of the consensus. Do these 50 people actually agree on the right label? Is it high quality? Can we trust it? And also, is there any way to do this without shipping the data out? And also, can we do it without paying 50 people to do it? So what came after that was this concept of labeling functions. And we saw that with companies like Snorkel. And they had a really good idea, which was like, let's look at text. It didn't work so well for images, but let's look at text and say, look, if we can write some function in Python, if I can get an engineer, a software developer, to sit down and say, I can map all of my data into labels just by writing software functions, and we'll build software around that then finds a decorrelation among all those labels in order to say this is sort of the best label for that data point based on all the rules you wrote. And that saves some time and cost. That cut down on, it increased the automation. The downside of that is what it produced is something that Snorkel and companies like that themselves call weak labels. So basically noisy guesses of labels, but not high accurate, high quality labels. Another downside is it required engineers to actually write the code to produce those. And another downside is that it only worked for things where you could actually systematically label them. Like, for example, text, where you can say, an example would be, I want my wife to grab, to make food for me or something. and then it would say that the speaker is most likely a man or something, or husband. And of course, that's that can be wrong, but basically you're just doing your best, and you can see how that label could be wrong, but it's still a labeling function. And so that's an example. So we got there, and that was a way you could automate some of the tasks. And then where we are today is what we're doing is domain specific AI training that looks at these data sets and is actually producing a label for you based on a small subset of labels, but then going way beyond labeling. So what I focused on was just labeling, but actually most of the error is not just in the label, it's in the data itself. And so we extended that beyond automated labeling and automated detection of errors to outliers, ambiguous data, which means it confuses models, PII issues, etc. So I talked for a while. I'd love to share a use case of this if you guys want.
Yeah, before we get into a use case, I do have one follow up to that, because you're right. I think the idea of almost subjectiveness and kind of ambiguity and vagueness. I'll come back to your example of like, I want this person to make food for me. Well, context is now going to be the greatest input here that you may totally be missing in that text sample. So in your philosophy, or in CleanLab's philosophy, is CleanLab an alternative to things like gathering consensus, or do you prefer that to almost work in parallel, or in a pipeline where CleanLab maybe is showing something as ambiguous and vague? Perhaps that's more of a short list now for the actual domain experts to take a look at it and readjust it to some process. Like, what's the philosophy there between combining some of those paradigms?
Yeah, any customer of any of the products, that we've already talked about, any labeling product is a great customer for CleanLab, because what they can do is reduce the number of annotators they need and then put low quality data into CleanLab and automate a lot of the time and cost. And so you can see it as a next step, or you can just feed the data directly into CleanLab and then do a few initial labels yourself, and then let our system iteratively get you there. Either works, but I think of it more as any customer of a labeling company is definitely a customer of CleanLab, but not vice versa. A lot of our
Awesome.
users, they just want to actually get the business value, not just label data.
Makes sense. All right, let's hear a use case. We are practically intelligent, so we want to make sure everyone has a really clear use case. So tell us how you are actively helping or in this use case.
Yeah, one thing that you could search online today, it's a blog I think called Money Talks, and it's for a big bank. You've probably heard of them, PNC in America. Globally, they're called BBVA. They're one of the largest financial institutions in the world. And they posted on their website, not on ours, just to show like where the source is coming from, that they were able to reduce the total amount of spend and time in terms of getting a financial predictive data set to predict accurately what a financial outcome would be. Like, should you buy something or not? Is this a good loan or not, investment or not? Based on financial data and text document data. And they were able to reduce the total number of time and cost by 98%. That is an extreme example. The amount of principal of a big bank like that is going to be pretty high, typically in the millions. And so reducing costs by 98% is a factor that I would not promise your average person. But we are seeing time and cost improvements between 70 and 80% on average. 98% is, of course I'm sharing that because it's an exceptional example by a massive organization. And in addition to that, and I think this is the real kicker, is after using CleanLab, they also saw model improvement by over 20%. So the accuracy on a held out test set for a financial task was increased by 20%, even though they spent 98% less.
Yeah, and we'll put a link to it in the description, of course. And when you listener actually take a look at that post, you're going to see basically what almost looks like a duh moment. Like, well, of course they had to build a training set and evaluation set, train the model. There's a nice little graphic there of annotation and notifying things, which is basically proposing samples to be labeled. That cycle that you see on that post is basically the cycle you'll see on any machine learning or ML ops course, right? The idea of train the model, you have a data set, you have to improve the data set, you train it again, and you test it. So in a lot of ways, when I think of a company like CleanLab, I think of, well, this has been what we were trying to do this whole time. And it's only just now, frankly, that with the advent of transformer technologies and much faster processing and cheaper compute, that we can actually fulfill this promise for a larger subset of people who have this problem but never really had the resources to solve it, whether it was someone who worked at the company telling them they had to do it, or some kind of advisor kind of intervening in the process. So I think it's going to be almost like a shock to the system to see like how easy CleanLab can really make this. And so I really love that use case. And you're right, it's dramatic because it's a really great example, but it also shows the boundaries in which that you can have the upper boundaries of, maybe not even upper boundary to even go even higher, but it can be as dramatic as 97, 98% change. It can be that much depending on who you are, what you're spending already, and what processes you have in place. So I see that, yes, as an extreme example, but I also see it as this could be you kind of example, whether you're as huge as a bank or as small as a startup going through YC. And to that end, let me ask you, how does Clean Labs work when you aren't a giant bank, when you are a relatively smaller company? Like, how does that work?
That's a really great question. So another one of our enterprise customers is Berkeley Research Group, which if you haven't heard of them, they might sound like they're out of Berkeley, the university, but this is actually a pretty big company. They're 1,100 employees. We classify them as one of the larger on the SMB scale or on the smaller on enterprise scale. They're basically a technical and digital consulting firm. What they do is work with big legal clients, economic cases, all sorts of use cases like that. And they help them with ML and data tasks. So I'll give you an example. Say I'm a high profile person. I have a big lawsuit coming up. And this lawsuit, the case proceedings are going to be made public for whatever legal reason. So some of my privileged and private confidential documents will be made public as part of the court case. For example, Elon Musk's tweets or internal IP from a company. When that type of stuff happens, these court cases, in terms of the diligence required to look through those documents and make sure that nothing that doesn't have to be made confidential for the public is not made confidential, can be around $1 million or more per day. And we were able to save this company, Berkeley Research Group, in terms of a legal case that they were supporting one of their clients on, about 30 days off of the court proceedings. So the amount of time taken for them to analyze the documents and get the lawsuit going, that we save them about a month. And so I'll let you do the math. Can I contribute, every single aspect of that month to us? No, they were using our results and working quickly on their side as well. So somewhere savings between 1 and 30 million, something like that. And in addition to that, they were able to improve the model, the accuracy of the model that was doing privileged document detection and confidential document detection by 15% accuracy, even though they're also shaving off the time. The reason I brought that up is because the number of documents was not that big. So this wasn't a massive company like a big bank or a massive FANG institute doing hundreds of millions of data points, which we support, by the way, and that's our bread and butter. But they're actually more of a boutique, right? Where each document is complex and complicated, and we're supporting their use cases that was on the thousands of documents.
And they're not even complex, but they're also, you kind of hinted at this, they're very domain specific, right? And that kind of comes back to the idea, the promise almost that you made earlier of handling any data, right? Not just text, not just images, and not even just text, but text in the legal field, text in the financial field, text in the healthcare field. What is your personal or company vision on how to kind of create this almost standard, or maybe that's not even the goal? Like, how do you think about a system that can handle, quote, any kind of data? What are the main difficulties, and what are the main kind of through lines that go through these different modes of data?
Yeah, a lot of it was technical, Sinon. We did that work for like a decade prior to the company. So a lot of that, so all three of the founders did their PhDs in computer science at MIT. And sometimes I'm nervous to share that because while there's obviously some validation that we've spent time thinking about this, and we might be the right people to have built it, sometimes you hear that and you think, wow, this is probably an academic thing. And it's like, no, we're business people. Like we are here to support real value for enterprise companies at scale, and we focused exclusively on that task for several years. That being said, a lot of the work really was technical in the past. And so what we built was a way that you can not only train any model on any type of data, which is commonly known as AutoML, where you basically just give it a data set and then train any model, but also how can you find errors in any data set, regardless of the type, which is a framework that I did my PhD on called Confident Learning, which we have now extended into the full sort of suite of data-centric AI. Two bullet notes to make on that is that we taught the first data-centric AI course. It was at MIT. And you can find that. I'll put a link, I'll share a link so that you can share it with listeners.
Yes, please.
It's just DCAI at csail.mit.edu. And so that's one thing, is that we've really spent a long time finding a way that you can generalize this to any data set prior to the company. So this is a over a decade pursuit. The second thing is that, as I mentioned, the key and core to making this technology work is having the best AutoML in the world. And it's a lot of times you hear a small company, we're like between 30 and 40 people. How can I say that we have the best AutoML in the world? Like, you should doubt that. And I would expect you to doubt that. And to which I would reply that the person who built Amazon's AutoML, which is called AutoGluon, it's open source. And so you can look up who committed the most GitHub commits, was Jonas Mueller. And he's our chief scientist and co-founder at CleanLab.
There you go.
Curtis, we talked a little about the history of data curation and labeling. Fast forward to 2027, 2028, in a couple years from now, any predictions on things we're going to be talking about then more in this space, whether it's, example, synthetic data, training data scarcity becoming more of a thing, just general topics that you're paying attention to as a forefront and leader in this space, that your customers are paying attention to, that you think we're going to hear more about?
Yeah, the future question's always good, right? Predict the future, and then 10 years we can play this and see how wrong I was.
Yeah, but no one quote this. If you're listening, don't quote this.
Yeah. I would, we can quote it. I'll do my best. I would hope you don't, but it's fine. It's out there. So I think there's going to be a lot more multimodal work. I think we're going to see images being described by text, and text being described with or being sort of supported with images. I think we're going to see more tabular data combined with text data, a lot more multimodal. So instead of it being about sort of this like computer vision where we just look at things, I think it'll be computer vision plus statistical data and tabular data about those routes and other statistics for self-driving and mobility. I think that we'll see in the healthcare industry, it won't be just a prediction based on a medical health record and text, but also all the tabular data of that patient prior, and also visual imagery data of body scans, x-rays combined into single predictive workflows. So that's one thing. I think we'll also see an increased demand for speed of innovation. I think if you look at sort of what AI has done, is it's allowed us to create faster. And I don't think that's going to change, which means that I think what we'll start hiring for and training for is not someone to do, for example, what I did, which is know every detail of how all the ML algorithms work, but instead to actually get really good at understanding how to be creative and how to be curious and how to push buttons on an AI system and see what pops out, how to squeeze it and mold it and poke it and see what comes out the other end. I think we'll find that people who think that way, who see life and AI as a sort of bubble we can poke at and see what pops out, instead of being forced to work within the constraints of AI, but instead how we can mess with it to make it do things it's never done before. The people who think that way will become the leaders of the future versus people who just know every detail of how to build these things.
Yeah, no, innovation is definitely feeling exponential right now. I think on that note of being curious, Curtis, I happened to actually didn't know this before the call, but come across CleanLab Studio, and I think it's tough when you're listening to this on a podcast. You're like, get a feel. People are familiar with the sort of workflow of essentially working through and improving your data quality and labels, but it's a phenomenal product. It is, essentially lets you try that for free, and also has like automated deployment out of the box. And so, would encourage our listeners, if they were excited about the history, maybe the stuff Curtis talks about, to go check it out. It is
of all the links we will put in the description, it'll be the first one.
Yeah, for sure. Well, but thanks
you.
so much, Curtis, for coming on, and really, really appreciate you taking the time.
Yeah, and thank you, Akshay, for adding that. If I may, I'll add one thing, which is I tried really hard here not to like market and be like, buy this, use this, and I'm still not going to do that. What I'll say is that the people who have built this thing, every single one of them could have done tremendously good things out in the world on their own. And we have an obligation at CleanLab that if we're going to build something, that what we do collectively as a team is at least as good as what they would have done independently on their own. And we feel that every day at CleanLab. And so we really do try to create something that creates real value for people every day. It's bread and butter for us. It's what we care about.
Amazing. Awesome. Well, Curtis, thanks so much for being on the show, and we'll talk soon.
Thanks. Yeah.
Thanks.
Appreciate you guys.